Okay, it looks like we are live. So welcome back. Today I'm going to be continuing to work on Kano script. Alright, so let's see. Today I would like to work on stuff. Let me read this. I discovered an issue, which I'll go over in a moment. But today I'd like to make another way to allocate memory, right? So basically equivalent to malloc in C. So basically it's gonna look something like this. Pointer equals alloc, and then the size, right? So say 8. If you're allocating a pointer for that. For now, I'm just gonna have a pointer type, which is gonna be like basically a void pointer. In the future, I'll add, I'm not sure exactly how I want to do it, but like, could be that, like you use p or maybe like a star, like how it's done in C, something like that. But for now, I'm just gonna have pointer, right? So alloc, that's gonna return a pointer, so it's gonna be an expression, right? But it's a native function, so similar to write. So I do need to change some of the ways that things work. Basically, alloc that, and then yeah, so that's basically the goal for today, is to get that work. Now the issue that I found has to do with global variables. So right now we can define a variable like this, right? A global variable, and then we can reference it in a function. So if we do something like this, x equals x plus 1, we set it equal to x equals 1, right? And we exit with x. Okay. So if we do this right now, it's going to exit with 12, because we don't actually call that. So I built that. I don't really build it actually. Let's see. And that's not the right thing. Okay, try that again. Run, echo, and exits with 12. If I call this, then it's going to exit with 1. And that works fine. Maybe it does not. I'm not sure why it stack underflow. Okay, I was testing, and this didn't happen. Let's see. It's because of this pop here, isn't it? Yeah, that's because I say this returns value. Yeah, it's actually a void function. I need to remember that, because I don't have a way to detect that. Yeah, that's what the issue was. So there we go. We did that and exits with 1. That's all. That is all good. Now the thing is that we need to consider is if we declare a variable here, so y equals 15, it's gonna throw the whole stack up, and I'll go over y in a second. So let me just run and echo that, and we exit with 12, because it didn't actually replace this. If we try to exit with y, it's gonna be 1, because it basically overwrote y, as you can see. So the reasons happens is we have the stack, right? Like, say this is the stack. So we actually do 12 and 15, right? That's on the stack. When we get to this point and we're compiling this, we don't know about this one. Yeah. So basically, it pushes this on the stack, and then it saves that stack position, and also the stack size here. Yeah. So that's basically why that happens. So yeah, it's trying to grab this value, and it thinks it's at this position on the stack, so it tries to grab this one. So I thought of a few different ways we can fix that. I'm not going to talk about it now because that's not the focus of today, but I just wanted to go over that. I did make an issue for that, and that is obviously very urgent to fix. But for now, I'm not going to be worrying. I'm not going to be worrying about that. Here equals L8. Yeah, so basically this is what I need to compile today. That's the goal. Okay. Yeah, bit of a tangent, but it is relevant. So first of all, maybe I'll add the pointer data type. PTR, right? And yeah, let's take here, sure. And that's 3. Okay. And do I have, yeah, so I'm not going to do anything with that. I do have to do it in the parsing, I think. Parse variable declaration. Token consume. Actually, do I have to do something here? I don't think I do. I think I just need to add it in the backend, right? So in here, we have to add the type. Where is that defined? Right here, okay. Yes, we need type PTR. Yeah, which is basically just a void pointer. For now. And then in here, we have this, and it's 8, of course. And yeah, so I think that's pretty much it, right? So that should compile. Let's say I do this. So there's no type thing still, but if I do something like this, that should work. So you type return item. Okay, so maybe it didn't work. So I forgot something in the front end, right? So parse variable declaration. Actually, did I spell something wrong? PTR. Yes, PTR. So that's right. Parse var def. Let's take a look at that. Node var type is that. It must not have... Did I not rebuild? Actually, that was the issue. Okay, yeah, so that works. So it did parse that. It just parses as like an integer basically now. Because we don't have type checking, but regardless, so it's sort of like a generic data type. But obviously that can cause some problems. So yeah, so we have that. Now we need to actually implement the new native function, and we need to parse it as an expression. So here we have this. So yeah, I need to add the token type. I'm just gonna put it after the exit here since it is relevant with that. Exit, and we'll have alloc, right? And we're also gonna have dealloc and store and realloc value as well. Things like that. But for now, token type alloc. That's all that we need. That's all we need to get started in this. Maybe we don't need realloc actually, because if we just we can implement that as a function, right? Token type realloc. Not realloc. I'm sorry about that. Okay, alloc. Token type alloc. Okay, and then we need to parse it. Parse it native. So we can handle this. So case of that. Type. Yeah, so really that's not like we're basically just parsing the expression at this in this case. Let's do really we don't want to do this. We want to handle it in the parse expression. So we can parse primary. And in here, if the token type is one of the native types. So really I should kind of combine them all together, but for now I won't do that. Token type it's not equal token type alloc. Yeah, so instead of having different token types for each one, I'll have a token type native. So I need to change that. I'll probably do that today, but for now I want to get this working, right? So case of... I actually won't put it there. I'll put it after... Alright, case of alloc. Then we need to parse native now. So we need to export native, right? Export native. And then token value dot native equals parse. Do you want to parse native node or want to parse the yeah, parse native. I suppose makes sense, right? Is that right? Hey, let me think. Yeah, I think that's fine. So parse the native node of not the expression, but the token dot value. Do we have what values do we have when we allocate that? And what do we have to parse native node? What do we have to pass here basically? So we need the tokens, the type that is expected, which that doesn't really matter, and then the native value. So the native value of alloc. Shoot, is that what is it? No, okay, yeah, it's not really a native node like that then, because it works a bit differently. Right, we really just want it to be alloc. So in that case, yeah, I might need to do something else. Right. Tokens. Because like it's not any of these. So yeah, I need to kind of handle it differently. Because basically the way I'm considering it, with the way the other ones work, we use like, say for example, native 60 is exit, right? And it pops off the stack and things like that. But with this one, it's just alloc. It's not like it's a built-in thing. It's like a keyword basically. So it's not really a function. So I don't want to parse it like a function. I want it to be still a native node, but maybe I should handle it differently. So I'm just trying to think, what do I want to do for it? So we need to parse the expression following it. How does parse native node? Let me go back to that. So we token consume. That is this one. Type equals type native. So it's a native node. That's fine. And the token is that. Switch over to type, and we parse the expression for each argument. And that is fine. That's probably fine. And we append the args. Why is there just a single arg? Okay. Yeah, call type. So really, it's kind of different than that. I was trying to think, how do I want to handle that? It's like a built-in thing. What's the... Okay. So what if I don't handle it like that, and instead I make a new function? So like this is the node, and it's gonna parse built in, right? So it'll be a built-in. So we'll switch over these, right? So we need all the tokens. And then what else do we need? So we need, I guess, the built-in type. We need that, and basically, okay. It froze again. So that happens sometimes, and it has to do with the auto init thing, and I need to work on that. Now I don't know where I'm at. Shoot, did it? Did it get rid of all of that? Or did I save it? I did save it, so that's good. Yeah, so we want to parse built in instead. Built in. And it's not going to be a native node. So, value.built in. It's going to handle different. Built in. Expert built in, right? Built in. Tokens. And then not really token.value, but instead the type, which should it be set there? Alright, so actually it's going to be tt built in. And then along with that, we're going to have the value for it. So this will be token.value built in. So we should have that. So something like that, right? So let me add the types. So if I go to here, we have the token type alloc, but instead I want that to be token type built in, right? Built in. Okay. And then token value. Yeah, so the token value is going to be a built-in type. Built-in, right? This is going to be an email. Okay, built-in type. So we'll have, for now we'll just have alloc, but this will have built-in alloc, like that. But we'll have other ones, right? So this will be like the 0 one. And other keywords will be done in a similar way. Alright, so we have that. Token value, and then we have the token type, right? Yeah. So I think we're fine with that. I think that should be okay. So let's go back to here and parse primary. So yeah, basically we need to make this function now. So parse built-in node. Okay, parse built-in node. Token array tokens. And then built-in type. Okay, and I'm going to try this again. Okay, did not break that time. So I need to definitely look into that because that's a big problem. Yeah, where it kind of freezes and it gets stuck in an infinite loop for some reason. I need to use like GDB for it. Okay, sometimes replicating. Anyway, so the token. So we need to, first of all, we need to consume a token. So, well, we consume this one, and that is the, okay, this can't be TP alloc, it needs to be, oops. Needs to be token type. Was it built in here? Okay, so we consume that one, right? That is the one that we've consumed already. So we need to then, we need to basically just parse the expression, right? Parse expression of the tokens. Yeah, so we can parse that expression, and that's going to be the expression that we use in the as the value code. So we'll need to actually make that value. Yeah, so I'll need like, I need to define another struct, actually. I need to do this a bit differently. So we need an enum, which is, and then we have the struct, right? So this is just a built-in. This has two things, right? So it has the built-in type, and then we need the expression, right? So this is the value. So instead of this, it will be that. And that's what we're going to return from it. So we're going to return a built-in from it. Which can just be an expression, actually, so that's fine. Yeah, so then, so this is the value, right? Okay, we can do this. Expert equals, so then we'll set the dot value equals that. And then dot type equals, equals the type. Okay, which we can pass there. So we do need to get the type, and then we can return expert. And I think that should work pretty much. So here, that is the value of this. So the only thing that we need now is to set the token value when we parse it. So let's do tt alloc. I think we still have that. can change this to built-in. And then how do we handle this, right? So when we, where is it? In the Lex, right? So we get this. Yeah, we factor switch table. We'll do that later. Get token type. Handle data type. Right. So get token type. Yes, we just return that. But how do we set the value of it? Do we actually do that when parsing? Was that ident is that? Yeah, so we get the ident. In that value. And actually, what are the different values that we have? Let me look at that. Yeah. Okay, so we need to set it. We have built in. We need the expert as well. The expert built in. So this really just needs the type, right? Yeah. So this needs to be a built-in type. We have to get the built-in type. Yo, hello. How you doing? So we can get the built-in type based on the name. We set that. Can we do that? Okay, yeah, let's try to let's make a function. Okay, so built-in type. Get built-in type. So just return let's do built-in none. So we're gonna need that. That's like the default case. And this is gonna take a string view. And this is the data, right? The serve. Okay. So basically, we'll just if you compare so is this the best way to do that? Because we already kind of maybe I will do this different actually. So I will just like sort of append to this, right? I get rid of this one, get rid of the alloc. And we just return the built-in, right? So we can do that's a token get built-in maybe token get built-in, and we need a string view here. So basically, yeah, we will basically make something like this. How are you doing? How are you doing? I'm doing good. Let's see. So right now, what I'm working on is implementing allocation, right? So right now, the only way that we can allocate anything is an array, and we can do it like this, right? So we can do something like that and allocate an array like that to the middle. But I'd like a way to sort of call to some sort of built-in function, and then allocate memory there, which then you can do what you want with it. So if you want to store just a single value there, or if you want to store an array of values there or whatever, similar to like malloc in C. So the way that's going to look is like this. So PTR, that's just going to be a void pointer type for now. In the future, I'd like it to be type base, you know, like int pointer, that kind of thing. And then you can do something like this, alloc, and then the size. Yeah, like malloc, yes, yes. It does call it malloc because it's built on top of C. That's sort of what the syntax is going to look like. Yeah, so exactly like that. That is what I'm working on now. So I can parse this pointer part, but all I need to parse is that right now, and I am working on that now, creating like an expression for it and such. Okay, yeah, so that's the goal for today. So this is outlet. Okay, very good. Then this is, I'm going to return a token. Actually, so what I want to do, okay, dot type equals token type outlet. Token type built-in rather. Value dot built-in equals built-in. So we're calling built-in here now. Which is what? So the dot type equals built-in outlet, and then the dot. We can't really do the expression actually, so it seems to be a built-in type instead. Okay, yeah. That is what we want to return there. exactly like that actually. So that should be good. Otherwise, alright, actually, how do I handle pass the token there? Yeah, so I can do the same thing as that basically. Okay. And just return the token like that. Yes, and that way, if there is none, then we can do that. So token get built in, so we need to call to that thing. Token get built in. Okay, pass the token, and then view create. Word data, word data. Instead of creating each time, I think it makes sense to be like this. So basically view equals all the videos on the virtual machine you built. I didn't have time to watch them for now, so I'm catching up. Alright. I did make them quite a while ago, so they're not exactly as good as they could. Okay. Yeah, then we can use that here instead. View. And view. Okay. Then we have the built-in. So then when we parse primary, we can call to that. We're gonna value that built-in the parse built-in node. Perfect. Okay. That we do this, and dot type equals type. So we already passed the type. So then that is all good, and that should be pretty much it. So let's go through the compiler areas now. Quite a few. Expert built-in does not exist. Yes, I need to create that. Expert type. Let's go there, and let's add expert built-in. Okay. Expert value. So we need built-in as a value. So what I'm going to do actually is move that definition to here for the built-in stuff. So built-in and built-in type. Okay, like that. And I have to remove them from here. Okay. Alright. Tone type built-in is not having a switch. That is fine. I can fix that. So where is the switch? 606. Case. Token type built-in. Okay. Some braces around initializer. Okay, I can do that. I got built-in equals this. Some braces. Totally cool. Shoot. Okay. What is that? So the expert. Shoot, I set the expert value. Yeah. Expert value. Built-in. Wait, no. Why does that not work? Hang on. Value.built-in. Yeah. So there's actually two things that I set to it. So that that's not quite. Okay. So there's two values that we set here. So we have the value built-in. Wait. Where's built-in? Returns an expression. Okay. Built that. Okay. This that returns that. This is meant to be comma as well. Store undergrad, yeah. So I need to. I just want to fix some of the other things, and then I'll get to this one. Yeah, it is view, not stir. Okay, I'm gonna type in expert. Oh yeah. So I need to actually type this is declared, or where rather. So I can take this and move it down. So we need to built-in that value is that. But then it is an expert, so right. Alright, so let me actually let me try that. Built-in. If I do that, then I return a built-in from this instead. Built-in. built-in, and return built-in. Then in here I can set I got built-in equals that. Yeah, but what is that about? So yeah, everybody is open, so I don't need to do that. Okay. Data built in that type. Value equals that. The dot type equals that actually. Right, is the built-in not defined properly? The type and the value. Dot value would be the expert pointer. Dot type would be the built-in type. So what is wrong with that? Runtime expert still. Okay. Oh, needs to be struck. Okay, so now we just have this. Why does it think it's an enum? The expert value should be an enum. Okay, where do I still define that in here? We have this for the token, but that's not what we're dealing with. So let's return expert here again. Let me try this. Expert, and then let's turn the pointer to expert. Oops, equals size of. Okay, and set I think that's okay. We can set the value actually. And that type. Actually, no, because that's not what we want to. Well, hang on, if we just call it to this. Yeah. Okay, we're actually setting it improperly, aren't we? I see. So expert is that. So what we have to do is. Hang on. So, I'm trying to think. Yeah, why don't we turn the built-in from this? Oops. And that is this. Okay, so it's kind of like confusing to wrap around with all the enums and stuff. If I use an expression and the type is that, we're going to return this, and that's going to be oh yeah, I feel like I'm really bad at this, but it's fine. Okay, that compiles properly. Alright, so I think that's good then. So now we have the built-in. We have the type and the value. And the value is an expression, and the type is going to be what we call. So then, here we can actually compile the expression in the backend, right? So gen enter. Then, so if we have a case of, let's go here, case enter built-in, then what we need to do is gen built-in, and we need to pass the save and file, and then the expert, yeah, we can generate it from that. So gen built-in and we'll add a break in. And I think that's all that we should do. So gen built in, and we're gonna switch over. So program state file. Expert. Okay, so that's what we need to do. Basically, we'll switch over expert. So we already know it's a built-in at this point. We just need to probably assert that. Assert that expert type equals expert built-in. Just to make sure. And then type is incorrect. Okay. Just like yeah. So that is something went wrong in the generation stage because we shouldn't be calling this function unless it's built in. So expert value dot built-in dot type. So we'll switch over that. And so we need a couple of things here. So in case actually this is all we have now. Built-in alloc. Alright, let's actually add some of those. Okay, break. And it's an alloc. I forgot something as well. In the front end. Did I not do that? Yeah, we just did that. Okay. Yeah, so never mind. I was just thinking about something else. So join built-in. Let's see. So case that. So if it's an alloc, then we just want to gen the expression within expert value built-in dot value. We also need the state of file. And then we need to basically just printf state file, and we want to print to the file alloc, right? And that's going to do a few things. So state stack size. It's actually going to be 1 off the stack size, which gets generated from the gen expert anyway. But that's basically all that we need to do. Okay. Let's see if that compiles. It does. So let me try it. And that should leave on the top of a stack a pointer. If I run this, alright, nothing failed. Let's look at the generated assembly. We do have alloc, so that should be allocating 8, right? Alloc, and if we print, it should be a pointer on the top of the stack. So if I actually run this, yeah, so you can see it's clearly a pointer. Type is pointer, so that's what it is. So we'll put the pointer on the stack of 8 bytes. Then we can do stuff with that pointer. Yeah, so we can basically use it as an array. So if we do, let's try 8 times 3, and that should work. So that should basically be allocating something like that. So if I run that, and I go to here, it should allocate enough space. Yeah, push 8, push 3, and multiply. So that should look pretty much the same as doing y int 3 equals. I don't know if we can, if I actually support that right now. Yeah, okay, so I need to actually support that so you can allocate an empty array. If I do that, so we should see, yeah, so you can see it's the same thing here, alloc. So we should be able to index it as well. So you can do that, and we can say x1 equals 1. Can I do that? Yes, okay, so just let me do that, and I should be able to exit with x1. And it exits with 1. Okay, so it looks like it did actually work. Try that just to make sure. Yes, alright, perfect. So, we do have that array, so that's pretty cool. Okay. Yeah, so now we have a pointer type. And yeah, we can generate this as an expression. So let me actually commit that. And then I will talk for a minute. And built-in expert alloc. Okay. So, right here. So, we have that. We'd also like to be able to free it, right? So as an expression still, but a statement, like an expression statement. So I would need to sort of implement that, because right now you can't do like something like this. And what this would do is it would evaluate that, but then just pop it off, right? Because we obviously don't want that on the stack. So if it's an expression statement, then it will get popped off, the value. Because it just will throw off the stack. But we want to be able to free the pointer, right? Or the alloc probably is. The alloc. Like that, right? Yeah, and also like a way to store stuff. Because you can use like, I guess it's right. So in this case, this works. Even though it doesn't know the data type, because the pointer is 8 bytes, and that's the same size as this, right? But if we try to make that if we made it, like, tried to do it with characters, it would not actually work. Because we have 64-bit integers and then 64-bit pointers, right? So that's why this actually worked. So we need a different way to store stuff when we don't know the data type. So it would be store, right? Pointer, and this would be yet another statement. Pointer. Value, so if we had some value, so we'll say like 15, it'd really be a pointer to value, but whatever. Probably would be the pointer, yeah. 15 at what memory location? No, we had the memory location, but how many bytes, right? So in this case, it'd be 8. Something like that. And if you wanted to offset this, you could do x plus 8 or whatever. Like to offset it, right? But that's sort of the idea behind it. Right. Hopefully that makes sense. Yeah, so we need to implement dealloc and also implement expression statement. So let's actually start with the expression statement because I think that is a bit different. So expert type. Let's see. Actually, it's really a node type, right? So we have this type expert. Let's do type expert statement. Is that what I want to call it, right? Right. So then that's gonna be. How's it gonna work? So then the value, I just want to sort of go through it. Let's see, do we have a node value? Let's see, expert is expert statement. Okay, so that will be that, and it's just gonna be an expression that we evaluate, and then if it's a statement, we evaluate the same way, but then we just pop it off, right? Because it's only gonna be one value at the end, because that's how the expressions get evaluated. Yeah, it actually shouldn't be that hard to implement. So making sure that compiles. It does still. So what we need to do basically is go to here, and we don't need to change anything in the lexing, but in the parsing, most of these places will be fall through. Like so, we built in for sure. String that anything that is an expression, right? So let's see. Plus, well, that's not really an expression. Like just start an expression. So string character literal int float built in. Eventually the natives, but really I don't know if we need that. Mod plus mult type less greater, not really any of those. Yeah, I think that this is it. So let's actually add some of those. Okay. Okay. So we basically need to gen the expression. Yeah, so gen expression. So that's gonna be the value. Let's create a node. Well, we already have the node, but the node dot type equals node expert statement. Then the node dot value dot expert statement equals gen, not really gen expert, but parse expert, and we pass the tokens. Okay, and then we just deal with thing. No, that's pretty much it. I don't think we have to consume anything else or anything like that. Statement. Yeah, it's type expert statement. I need to change that. Okay, make. Did not save. Okay, so that compiles. Yeah, that should be pretty much it. And then when we encounter one of those in here, check program, and we go, whoops, go to the end of the switch statement. We should have case type expert statement, and all that we need to do is, right, we need to gen expert value, expert value, expert value dot expert state, right, and then we need to gen pop state file state, yeah, state file. So if this has some sort of side effect, like how dealloc would deallocate the pointer, but then we'll also pop off the result of it. But if it's a void one, we need to consider that as well. So we don't have any moments yet, but do you mean expert? It's not expert, it's node. Okay, let's see. So if I do alloc here, it should work. And exit. Oh yeah, alloc. We need one of those. Okay, and if I look at the assembly, that's not good. So something broke, but it did actually allocate the pod. So like it did do that properly. But why is this messed up? Let me check it. Let's do that. Alright, yeah, it does not work. So for some reason, this gets thrown off. Let me do this. But if I get rid of that, it is not. Yeah, okay, so we messed up the stack for some reason. Why? I'm trying to think. So, let me print the stack size here. So, okay. Stack size is stack size. And then we'll print it again after this, and then one more time. It should only execute once. And it did not work at all with them. Oh yeah, because I got rid of that one. So I need to put it back out. Yeah, I forgot. I need one of those. There we go. Yeah, okay, so stack size gets completely messed up after the pop. Because it's set to 0. Why is it set to 0? Gen expert, that should push 1 onto the stack. But when it's one of those, actually, shoot. Gen expert, if I go to that. And let's see, gen built in. So is this wrong? We generate the expression, we call that, but then we do minus minus. But we want to, because this pushes it, right? Stack is that. I just want to see, so state stack size. And then do that, there we go. And let's put one more there. Like, what is the progression of it, right? Stack is 1, and then it goes down to 0. Wait, what? Oh no, it goes 0 and then 1. Yeah, 0 and then 1. Then why is it 0 at this point? It should be 0 then. So why is it 0? Like, we're removing it for some reason. So, we handle those. Expert built in. We gen the expression. And that's in, like, one of these. So let's go through these. Native right, variable reassign. It's something that is variable declaration. Equals that. Stack pose. Yeah, so it's subtracting from it. But why does it do that? I don't quite understand. If I get rid of this, let me just look at what it says. That's what I have to say. But if we look at the assembly, push this and we indupe 0. I don't get where it's getting messed up. Maybe I should run through it in GDB, because at some point, this gets completely messed up. So let's, that's not right, because I forgot the expression. So yeah, you can see it's 0 for some reason, but it's before that, and it becomes 0. Is it in the variable reassign actually? Like the, let's see, variable, what's really the array index? So, get variable location. Is this throwing it off? Okay. Stack size. Let's take a look at that. Perhaps it's 0. Okay, it's 0 at the end of that. Why is that? Let's put it there and there. One of those that messes it up. 2, 3. And what is it at the start? Zero. Okay, so that it's actually going back to what it was at the start. So that's not the issue. I actually moved the wrong one. Yeah. So you know what? Dot test. So. Why does that not iterate the stack size anyway? Still not right. Yeah. So in the gen expert, I don't know, it's kind of messed up. Where is, yeah, gen built in. So we go here, and let's print the stack size here. Use that. And we need to delete that, but okay. Go, stack size. When after we generate the expansion, we know that's going to be one less than after. 0, then 1, 0, then 1. So why is it 0? Yeah, let's use GDB. Let me get rid of this because it messes up GDB when you print stuff out. That's my break on gen program, and let's run with Kano.Kano. Yes. Okay, and we'll display state stack size. Oops. Display state.stack size. There we go. So we'll go through. Okay, variable declaration. So it should be a 1 at the end of this because we're declaring variable. Bam. Why is it not 1? Okay, so that's where our issue is already. We change the expression. So it gets messed up. Do that. Alright, let's actually run through that again. Let's step into it. Right, we'll step into this. And we go here. Gen built in. Okay. And let's see, let's display state.stack size again. And let's see, yeah, so it goes up to 1. But then it goes to 0. Yeah, okay, we don't want to consume it. That's the issue. Okay, that makes sense, actually. Yeah, I just had to think about it. So yeah, we don't want to consume it because it consumes one of those, but then it pushes a new thing on. So it just keeps it the same. Yeah. Okay, that's what the whole issue was. There we go. And now it actually works. Alright. Okay, so yeah, we can do that as statement. So like what we want to do is that, right? Dealloc X. And then that would deallocate it, right? So that shouldn't be too hard to do. Just need to add the built-in. So first of all here, built-in. Let's go to those. So let's do else if view compare view create built-in, not built-in, dealloc. That is how many? So, yeah. Okay, and then we return token.type equals token type built-in.value.built-in equals built-in dealloc, and I need to add that as well. And then built-in. Do we handle that? Yeah, so then token get built-in, parts built-in nodes. That's what we need to do, right? We don't actually need to do anything there, do we? Yes, that should be fine. Because it's still an expression in the same way. We'll need to do, obviously, type checking, but that's coming at a later date, so I'm not going to worry about that. Yeah, so now we need to add the built-in, which is actually, it's not in here. I think this one. So built-in type. So we need built-in dealloc. There we go. And this should all compile. It does not. So yeah, first of all, that's not handling the switch, that's fine. Hammer what? Oh, in the back end. Value. Yeah, I need to do dot value. That's my bad. Dot value. Okay. And then yeah. Then it all compiles. We don't need to add it to the switch now. Back end not C. 181. Yeah, we still should need to add it here. Base built-in dealloc. And yeah, it's gonna be the similar thing basically. Dealloc. Yeah, and then obviously you're probably gonna wanna plot the pointer as well. But I'll leave that up to the user kind of. Like just don't use the pointer anymore after that. Right. Yeah. I think that makes sense. Should be pretty much it though. Yeah, like 8. Yeah, like X. Then accessing it should be invalid and it might say wrong. But also might not. Expected in. Okay. Why did you expect it? What? Wait, in the... Wait, what? Why is it expect in? Wait, oh shoot. We need to put... Wait, no. Why is dialect expected? Let me look at that. Serious. Type dialect. Dialect? Yeah, it's not type. We pop the size. Wait, what? Oh shoot, did I not implement that? Might use a pointer at allocating at your own risk, yeah. And if you want to like reassign it as well. Things like that. Why does it say size? Wait, what? What is this? It's not size, it's the like the types are all right. But I don't know why it failed though. So let's try that again. I need to make that, but I need to make that. This, there we go. Size and equate, yeah. Bad. PTR. That's not that place. There we go. Okay. So it still says expected. Wait, why does it still say that? I have it in a lot of places, but I don't think there's anywhere that it would be. Send me the right. Right. Let me try something. Okay, no. Get rid of that and get rid of this. I just have those. So it's still from one of those. So probably from the oh shoot. Wait, what? Oh, you know what it is? I am stupid. That needs to be dialect. I had the wrong thing. Yeah, I did find an issue though, which is kind of fun. That like this was wrong because it was with the way that it worked before, like the error message and stuff. But yeah, probably could have better runtime messages anyway. Regardless, let's see. So we run that. I'm assuming it did the allocated, so let's try to set x1 equals 12. And if we exit with x1, it might say 12. Stack underflow, really? What did that? How did it underflow? There's a lot of stuff here, but we dealloc and then we pop. Yeah, because that is a void. Right, so this is the built-in is actually a void, so we need the return type to the built-in. Built-in. Whoops, I went past it actually. Built-in right here. So this needs to be type return type. Okay, and we have to set that in here. So we do that, and then we can get built-in and parse that. Yes. So we kind of need to switch over it though. Switch type, right? So case of built-in dialloc. Alright, well really yeah. We don't necessarily need to get too complicated now, but I think I will anyway, for future sake, right? I'm gonna set the built-in return type equal to void type void, I think that's what it's called. But then in alloc states it is a type PTR. Yeah. So in that way, when we do the type checking, we'll be able to check that. But for now, we need to just do it to know not to pop, right? Let me make sure that it still compiles. It does not. Yeah, because I forgot to break. Oops. Okay. And if we go to here now, and in the gen built-in, after we call it, no, it's in the statement. So if, shoot, we need the value of the whole expert statement. So that's a bit more complicated. So the expression needs a value. If expert, which yeah, I forgot about that. We still need the other one, so like we still need it for type checking in the future. But we need the return type of the expression. Does not equal type void. Then we want to do that. Right? Generate a pop. Otherwise, we do not want to do that. Because it doesn't return anything, right? So we need to set that. So let's go to devs expert. Yeah, right here. We need the return type. So in that same way. And I guess how we're gonna handle that is in parse finder. How are we gonna set the return type? Let's see. Well, we do have this. Mm, we set the return type here. Well, not really. Almost all of them. Well, actually, they're all gonna be. No. Most of them are not void. So if where's your desktop again? Nice, nice. Yeah, I think you posted in the Discord, right? Equals 50 Ti. Expert equals pipe void. We're working on the title like app. Very nice. Natural pipe void. Right, so how's that going? How is that going? What's your stack? It's not clear. Why? It's node. Okay, well, let's get into this statement. It's not yet node. We could even do expert statement. I see some error. This doesn't work. What index is that of stuff? Here we go. Echo that. Damn, I said that so many times. 12. Alright, so that works. But then we deallocate x. 7 in the deallocate. Let me go through this. So 8, 3, multiply them together. Right, so 24. And we allocate. We allocate 24, so that consumes it, but it pushes a pointer. 3 indicate the pointer. Push 1, push 8, multiply. Add it together. So yeah, plus 8. And then that's a void pointer, so whatever. We're ending up with a pointer. We push 12, we push 8, and we write, which consumes all three of those. Then we indupe 0 again, which is the original pointer, and we deallocate it, which consumes that. Then we indupe 1. But 1 doesn't exist. Okay. Just trying to indupe 1. Oh, shoot. Yeah. Okay, because we need to actually do that in here. So gen expert. It's actually getting to the thing. This needs to actually decrement the stack size. Because yeah, because of how it works, right? So this consumed it. This one we did not need to do that because it consumed it but then pushed the new back. This one does not push the new back. So I get that. And 135. What? Oh yeah, because it's garbage data. So yeah, it should be different every. Yeah, okay, so I'm pretty sure it has been successfully deallocated. So yeah, hopefully. Let me try running like allocate here. And does that mess up the stack? Okay, it looks like it does actually, it does consume it properly. Right there, so that's good. Let me just make sure, right? It's probably that. Let's tasm, and it does pop it. But if we do the dealloc x, which x doesn't exist, so let's do that. Alright, so that's fine. But I just want to look at the generated assembly. It should not pop. Yeah, I think it's not pop. Perfect. So yeah, now we can differentiate between the statements that are void and not void. And we should be able to actually do like any kind of statement now. So if we do 12 plus 3, that should generate it and pop it. So just say just nothing, right? Nothing program. But that works. And this can be useful actually. Like if I want to make a REPL for it, like you know how Python is, like this. 3 plus 3, and then it gives you the output. That would be useful, right? So that is another reason why you might want to do this. And like, this is pretty much supported in most languages anyway, but you know. So I'm gonna check. Okay. The Alec built in, and that's really it. Alright, so I'll push that. Not too bad, not too bad. Alright. Okay, yeah, so we have expression statements, which is quite useful. Specifically for things like this, like dialect, and then we're gonna have store, which won't return by either. Yeah, it wouldn't. Let's see what else. Yes, another thing actually I want to look at is we should be able to do this now with arrays as well. So if we make like this, then we can deallocate the array. So it's sort of like syntactic sugar is what this is now at this point. But it's like, you know, kind of a good idea to have. I don't want to have too many different ways to do things, but I think that is a fun. I want it to be simple, you know, like few keywords, things like that. But yeah, it looks like this works, and if I do this, it should be easy. Yeah, alright, looks good, looks good. Alright, so dealloc is working, so we can free memory now. So you don't have to have memory leaks anymore if you don't want to. Okay. So, what else? Yeah, so store, do I want to work on that now? So how's that going to work? It's going to work the same way with the write, because we have write. Yeah, it's going to be called store because we have write as a built-in, right? Or a native for it. So let's see. So it's going to look like this. So if we not declare, but we allocate, we do need pointers to types eventually, but not yet. Allocate, right? We want to store at x. Want to store. Well, how are we gonna get that really? We need a way to get pointers as well. I'm gonna store the pointer to another value. So let's say I equals 12. I'm gonna store the pointer to 12, or should we just store the data? The data at 12. But then if you want to store a pointer, yeah, so it needs to really be a pointer. Well, yeah, it needs to be. So we need a pointer to something on the stack. Right, okay. Let me think about it. So if we store like that, what do we need that? Store can kind of act as just an array indexing, where you give the size, right? So in this case, be 8. And that's it. So pointer, value, size. And that would store it there. And if you want to store more things, you could do it in like a loop, you know, so like, well, I need less than 10, so like, say that, then. And store x 12 at 8, so it needs to be x plus I. That value is to a pointer, so we need a way to cast it to a pointer as well, eventually. X plus I. You want to store, let's say we store I, right? It's gonna be 8 each time. Plus I times 8, so we need to do something like this. Times 8. Times 8, there we go. X plus that, store the value of I, and 8. 8 is the size each time, and we can actually declare I. So I equals 0, so we start at 0. We do I equals I plus 1. Yeah, so we'll store something like this. And that would be if you were doing it as an array. I think that makes sense. So do I want to do that now? I'm not sure. Store, and then we can also, well, okay, reading memory from it. Really would just be, let's see, do I want to basically do we just dereference the pointer? So like if we have that, we can just do like that, and that would read the value from it. Or, like, actually, probably not read, but, store and then get. We can do get. Get x, 8, right? That's how many bytes you want to get. And that would read the bytes from it. Okay, let me do that. And obviously, when you index it, you can do the same way as this. That could work. I think that makes sense. let's see. So store and get, and then we can work with memory like however we want. So we can store whatever values we want there. We can get whatever values we want. We can free it, allocate it, all those things, and then pretty powerful. Yeah, and then other built-ins that we have would be like open, right? To open a file. Write. I guess I would call it write. Because I'm gonna have write for writing to standard out. I could change how it works and make it like write one or standard out. I don't know, I don't want to do that. I want to just keep it like that. Write to a file, right? So say you get the file pointer and then the data. Yeah, that makes sense. And then also freed, same thing. Yeah, file pointer and then the amount of bytes you want to read, things like that. So it's basically just calling the C function. That's what that would be. Yes. And then, once you can read and write to files, could technically make it self-hosted if I want to. Not the virtual machine part, but the actual compiler itself could be. I probably wouldn't do that, but I could. Okay, yeah, so let's maybe think about store. And like that. So x, pointer to it, the value that you want to write, and then that. Okay, so that's not going to compile now, obviously. We need to add some stuff. So first of all, right. We need to change how we're handling the value of the built-in. So it needs to be an array of expressions. So let's go to built-in. Yeah, so this needs to be expers. So this needs to be moved down below where we define this. So just move it down. Like that. Okay. They want expers. So it's going to be an array. It doesn't need to be a pointer though. Expers, and then that's going to break a lot of things. First of all, in here, we'll have the built-in. And we want to set the value. We want to append to it, right? So while alright, so what we want to do basically is we want to first of all delete the built-in, right? And then we'll set built-in DA append actually. DA append to built-in dot value. Want to append parse expert tokens, right? So we'll need that the first time. And then while token p tokens doesn't need a pointer. Token doesn't need double pointer rather. 0 that type equals token type comma. Want to just basically keep doing this. The appended. And then once it's not a comma anymore, that means we've reached the end. So we can break out of that. So we'll end there. Let me set this, and that's pretty much it for that. Now still not gonna work in the compiler. I wanna say compile. Shoot, that's not good. Wait, did it say? Yeah, okay, it did say. So that's not good. It's on back end. And then built in, let's go for that. So this value. So this one only has one value. And it needs to be divided by data. Data. Alright, run that, and I'm just going to token that. Because we don't have stored, so let me actually get rid of that. Alright, and that should still work. So if I do x1 equals 12, we don't have x1, so let's do 16. So let's say with x1. Run that for that, and it should be, well, alright, perfect. That still works. So now we need to store, right? Store x 12, 8. So that's the data type. So eventually I'm going to implement, like size of I64, something like that, right? But not yet. I don't have that yet. So size of 8. Because that's the size. I need to add that keyword as a built-in. And again, we'll go here. Store. 2, 3, 4, 5. Built-in store. Okay, and that's all that we need there. So in here, we need to be good. The built-in type, actually, built-in store. Okay. And then we need to switch over in here. So go back in here. Let's see. We should get actually an error, like not an error, but a warning. So that is not handled in the switch. Built-in. Oh shoot, we didn't put something in there. So what's it actually? 428. We can handle it here. Yeah. So this is gonna be store is gonna be a void as well. So this built-in store. Most of them are probably gonna be void. Maybe not most, but a lot of them. Okay. Yes, now we need to add it to backend.c. Add 1. I don't know why it makes it go away. Alright, have a good one. Have a good one. See you next time. Have a good night. Zero, well, I is less than expert value, that value, that count, I plus, and we just want to gen expert. And actually, that's not exactly what we're going to do, is it? We want the first one. Actually, if expert value built in value by count not equal 3, so it should be 3. Then we want to print an error, right? So print error. Expert location. Let's see. Our 4. It's gonna do a pretty bad error message right now. For store. And there we go. That's actually great. And then we don't really want to iterate over it, but instead we are expecting 3, right? So we have 0 is the pointer. So let's gen that expression. Alright, how does the read work actually? What is the order of that? Let me go to here. Force and let's see, ins read. So the size, that's gonna be at the top. Okay. Size and then the pointer. Hang on. Inst read. Okay, we only have the size. Wait, where's the data from? Oh shoot, yeah. No, we're doing this right. Yeah, I am times 2. Oh, we have size, data, so it's actually the same order, so that's all good. So yeah, we can actually still use the order. Expert value. In that value account. Plus, and we just want to gen expert of state, file, expert value, built in that value, data I. And then we want to print that file. And we want to call right. And then we want to do state stack size minus equals 2. Because basically we push 3 things on the stack. So we push the pointer, the data, and the size. And then we consume 2 of them. Well, we consume all 3 and then we push a new thing. Do we push a new thing actually? Or does it actually consume it all? I think it actually consumes it all. So we can just get rid of the whole thing, right? Because we don't push anything new, do we? Hang on. Yeah, we don't push anything new, so we're good with that. Okay, so right. Ta-ta. Yeah, I think that should work. Statement may follow through. I forgot a bit here. And here as well. Alright, so let's go here and let's look at this. Store that. Okay, run. Okay, that. I found that. Not equal. What? There is no equal. It doesn't want the comma for some reason. It doesn't like it. So in the that's in the parts, right? Parts built in. We have that. So is it? Oh shoot! You know what? We need to token consume. Oh yeah, because we have to consume the comma. I don't know why it says it's an equal though. I think it's because I didn't actually add it back. Frame no so we should see a write. So we push 12, push 8. So it should be writing this data to this pointer. So if we actually look at this, we try to read the exit with x1, should be 12. Or x0, right? That kind of 12. Okay, that's not good. This is messed up again. Wait, is that not a void? Should have seen as a void. Wait, hang on. Put some store in dialog is type void. That's what it is. I do something wrong in here. Built in. Yeah, so I don't know why it generated a pop after that. After the right. So it did not see the correct thing. So, like void. What do I have that? It should be saying it's a void here. Oh shoot, you know what? I forgot that in here. We can actually do that. Return type equals. That's not right. I'm messing something up. I have type void. Yeah. So if the return type, we can check that instead. And then we won't have to update it each time. Equals type void, then you can do that. And if we go into here now, it should. There we go, x up. So we are storing the value. We should be able to do x plus 8 and store it at the next one. Good pointer. Okay. Because we don't have a way to cast it now. So let me compile this. I'm gonna have to. Yeah. So we're gonna have to cast it to get this to work. Or we could implicitly cast it if you add to a pointer, but I don't really want to do that. So, let's see. Basically, it is here. We need to do 2VP. What we add here. And then this will work. And there we go. 12. Yes. Yeah. So we need one to cast. So it's gonna be something. It's gonna be another built-in. Well, it's gonna be several. Then. So 2 void pointer is what that would be. And we could even do that. 2VP, 2 int. Yeah, okay, 2 int, 2 float, right? 2VP. That's what we want. And then we probably want to wrap it like this. And there we go. Like, you don't have to do that, but it's gonna cast it probably wrong if you don't do that. Then we'd be able to interpret that. So, I mean, I could do this right now. Let me see. So, open 8. Alright, let's see. So, if I actually add that as another built-in. So, built-in. Built-in 2VP. So, yeah, it's going to be sort of, I'm going to have to implement it for each one, but that's okay. Each type I want to cast it. Well, I mean, it's going to have to be like that, obviously. Built-in, let's see. So we need to add a new one for all the casting types. 2VP. That's actually 4, not 5. Then, wait, is there somewhere else I need to go? Yeah, so here we have to add the return type. So there is, it does, it is a pointer. Base, built-in 2VP. Okay, any more built-in? Yeah, we shouldn't have to do anything for that, so we should be okay. Then in the back end, built-in, we should be able to, we have this. Basically, all we have to do is take the evaluated expression and then put 2VP. We don't take them in the stack size. This is actually 2VP. Okay, and that should be like about it. And it did actually work. Okay, so if we run it in the echo. Yeah, we actually implementing casting. Alright, for 2 void pointers, right? So I think it might work with any type. Let's see. Some of them will have to actually look at the type, the current type. So how are we gonna do that actually? Look at the type of the expression and then do like we're doing 2 int, we need to look at it, and if it's an integer, well, we don't have to do anything. If it's a float, we have to cast it from float to int. If it's a pointer, we have to do pointer to int, things like that. Let's go into here though. So okay, now 10.c 2BP. That we just set the type equal to that. So that works for integer to void pointer, but if it was a float, it would not work. But we don't have like a lot of support for floats anyway, so that's fine. But yeah, so we can do this. 2BP. So like instead of like the C syntax where you do like that, void x, right? That's what it would look like. Instead we grab the whole thing that we want to evaluate. And you know, it would actually work like that in this case. Maybe not. Does it not see this as an expression? It should. You know what? It saw. Did it see my separate ones? It shouldn't have. But yeah, so that does work. I don't know why it was the incorrect amount, but this works. Right. So to void pointer, we can also just do p. Yeah. Set x equals 2p x plus 8, and then it could be use that here. Just use x. And x with x0, because it's gonna be 0. And it's the same thing. Yeah, but you can make this y pointer and do that, and then x1 it should say multiply. It's a pointer to it. Yes, okay. So yeah, we basically have pointers now. We can allocate them, deallocate them, store stuff. Really the only way we can read it right now is from this. But we might want a better way to do that. Like, you know, if you have just a single value, you could technically access it like this, x0, right? I think you can do that in C too. I'll make do it. Try. I'm pretty sure you can. You can do it. I don't know why. Turn 0. So basically, we have a pointer, right? So int pointer equals value. Size of int, and we'll actually include the lid. And then if we just printf set b, and we can print, we can do this, right? We can do that. Everyone knows that. GCC, let's see, that's our main, that's one, pointer, and I missed, yeah, okay, I forgot that. I forgot how to use that thing. Anyway, fuck that word. Okay. I don't remember how to use it. Pointer is on. Oh yeah, I need to set it to length. So let's do pointer equals 12. Why doesn't that work? Alright, now it works. Okay. So we can do that. We can run main. And it's 12. Alright, can we do x0? Does that work? Yeah. Okay. I thought so. So we could do like this as well. Because that's basically just syntactic sugar, right? Yeah. Right. I would still like when you do that. It's like a store. So if you do it like this. I can probably show it in a better way. You know. So just new dash r good. Okay, and let's see. I don't know. So yes, we store. So we store, not store, but we read. We read from y, and we just want to read 8 bytes, right? And that's it, right? Yeah. So like you want to read 8 bytes from it, and that would be the same thing as doing this. You know, same thing, but what? Yeah, we have more like precise control. Yeah. And also like this, we have to do a lot of type checking to get this right. Because if you want to, if it's a, like right now we can't support that because it's all just 8 bytes, right? So if this was an array of characters, which are 1 byte, then we'd have some issues, right? Because if you're trying to read 8 bytes ahead, so you'd be skipping and things like that. Yeah, so I think we'll commit that, and then I think that's probably good for today. Yeah, whoops. I got a decent amount done, actually. So yeah, we can allocate, deallocate, store. Soon we'll be able to read. I'll need to think about that some more. I think that'd be good as well. Obviously, we still have, like, the treating as an array to read from it, of course. Let's see, so what else do we have? So we have that. Then we're working with that. Probably should do something with structs soon. So structs are on the agenda, right? And once we have that, like, we can do a lot of stuff, you know? Then everything else on top of that is pretty much just, you know, nice to have, but not necessarily essential. Like structs even are kind of that, but it's pretty nice to have structs, right? I still have to fix that issue that I was talking about though with the scope, right? With the global variable. So I have this issue here. Like this is an example. It exits with 12, right? Because it treats y as 12 because it gets messed up. No, it doesn't exit with 12. It exits with 15. Yeah. So I actually made a mistake when posting that. That's sort of the idea. So yeah, that's actually gonna be about it, I believe. Yeah, so thank you guys for watching, and I'll see you next time. Bye.